We've looked at domain and range, and now we're going to look at domain and range from a graph. So remembering the domain refers to the x values and the range refers to the y values. So graphs, what we're going to talk about today, can be ordered pairs plotted on a coordinate plane. They can be a continuous line. They can have one arrow, two arrows, or open and or closed endpoints, which we'll see a little bit later. So this coordinate plane right here, we're going to look at the domain and the range. And so I'm just going to have us write down what each point is. So the A here is at 2, 4. And the B is at 2, 1. The C is 5, 3. The D, put that up here, oops, is 4, 2. And the E is 5, 0. So remembering the domain will be all your x values. So the domain for this problem, put it down here, do these little squiggles if you can, and you're only going to write the value once. So you see the 2 shows up twice, you only write it once. And then try to keep it in order if you can. So the domain is 2, 4, 5. Now the range would be all the y values. So I'm going to try to keep it in order here. We have a 0, 1, 2, 3, 4. So that would be how you would write your domain and range for a coordinate grid where you have just points that are plotted. Now down here at the bottom we have a line. It goes on forever in both directions because it has the arrows on either end. The domain in this case is going to be all real numbers. And the range also is all real numbers. In class, we looked at this on the graphing calculator. We used the trace function, and we talked about all the decimals that are in between. So I'm going to try and explain it here just a little bit. So this point right here is 0, -2. And then this point right here is 1, 0. And we can tell because those are the intercepts. They're actually on the axes and it's on one of those crosshairs. So it's pretty easy to say what that point is. But if you take a look at all the little points, say, that are all in here, all those decimals, we have to capture all of those decimals. And it's nearly impossible to do that because they can go on forever. The other thing is that you want to think about is because this line is extending, it's going all the way up, then all the way down. Every x value that you see on here this way is going to pair up with some y value, all these little x values. And the same thing, if you're going out here, all the x values in the negative, they're going to hit this line because it's going on forever. And that's why your domain is all real numbers, because it's just going on forever. And the same thing with the range. We'll go over this. I'll try and show you on the graphing calculator when we get into class. So I've broken up these next 2 graphs into 2 pages because one of my my sidebars is covering up the graph that's on the far right. So we'll do this on the course of 2 pages. Now here we have a continuous graph. So continuous means that it's a line, but you'll notice it has endpoints, which means it's not all real numbers. It does stop. And we are going to color this one in just to make this one easier. So both of these are colored in. And what this means is the first thing to do is to set up your domain and then your range and get your squiggles in. And then we put our x and our y. And if you notice, because these are closed, it's going to be a less than or equal The fact that they're closed means we need to have this equal sign underneath because we are including that point. So what's going to make it easier is if you actually look at this point and identify it and write it down. It's 0, 2. And then this point right here is 7, negative 5. Write those down because it's going to make it easier for us to fill in our domain and our range values up here. So let's take a look at our domain. Domain is the x, so we're going to look at our x values. The smallest x value between the 0 and the 7 is the 0, and then the largest is the 7. And then if we do the same thing with the range, the smallest is negative 5, and the largest is 2. The key to remember is the inequalities always face left. Okay, these symbols right here always face to the left. They are always going to be less than. You've created an inequality statement in a sense that says right here, x is greater than or equal to 0. And then you have also said x is less than or equal to 7. So you're making a statement, it's a range, it's a spread of data that's going to be between 0 and 7 for your x values. So if you're looking at your graph, at your coordinate grid right here, you can see that your x's are only going to go from here to here. Okay, those are your x's. That's as far as they go, from 0 to 7. And then if you look at your y values, let me try and get that off for you. If you look at your y values, they are going from 2 to negative 5. Those are your y values. And they're stopping. They have endpoints, and that's why you have to consider that this spread of data here. And that's how you would write this one. Now this coordinate grid is a little blurry, but I'm going to go ahead and tell you what the numbers say here. Over here we have, this is negative 4, 4, and this one is 6, negative 5. So look at the last example that we did and go ahead and pause and see if you remember what you need to be setting up. You're always going to start off D and R, domain and range. Get these squiggles in here. These are all closed circles, so we're going to do our less than or equal to's, and then fill in the blanks. There's your domain, negative 4 and 6, and there is your range. Remember to get the smallest one on the left first, negative 5 and 4. In class on Monday, we're going to do an activity where we're going to match some of these domains and ranges after we do the last two examples.